Hello once again, guys. Assalamu alaikum and good morning, good afternoon. In previous lecture, we were talking about the colligative properties and we discussed three colligative property. Right, the fourth one. After that, we are going to start with abnormal molar mass. Okay, okay. Please write here osmotic pressure. Osmotic pressure. Okay. So first of all, we will have to understand what is osmosis, and then we will understand what is osmotic pressure. Okay. So please write osmosis. Please write the process of flow of solvent molecules from a region of I mean region is better word will be solution of from a solution of lower concentration of solute. Okay, lower concentration of solute. So if there are less number of solute, so solvent number will be higher. So from lower concentration of solute to higher concentration of solute. Okay, higher concentration via semi-permeable membrane is called osmosis. Okay, so the main important point here is the flow of solvent molecules. So what is flowing? The flow is of solvent molecules. Now, please see. Let us suppose we have a chamber, something like this, and then we have a partition here. And this partition is the semi-permeable membrane. This partition is semi-permeable membrane. Please see. So this is chamber A and this is chamber B. So in chamber A, let us suppose we have just have solvent molecule. We don't have any solute. This is pure solvent. And here we have solvent plus solute also. Now, because we have added solute particles here, the vapor pressure will be lower. And here the vapor pressure will be high. Now, when the vapor pressure is high, so there is a pressure that is applied on this particular part on the chamber A. And when pressure is applied on the chamber A, and the solvent molecule has they have a tendency here. That means they can flow through these semi-permeable membranes. So what will happen? The solvent molecule are going to flow. Until when they are going to flow from the semi-permeable membrane? Until unless the vapor pressure is equal in both the sides. So please see what is happening here. We are having pure solvent, and here we have solvent plus solute both. So obviously, if I'm going to increase the amount of solvent, then the vapor pressure of this position is going to increase, and the vapor pressure of here it is going to get lowered slowly. So vapor pressure was high, it is getting lowered. Vapor pressure was low, it is getting higher. So there will be a time when the equilibrium will be achieved, and both the vapor pressure of the A chamber and the B chamber will be equal. And at that time, the passing of solvent molecule will stop. Now, exactly this passing is known as osmosis. Now, what is osmotic pressure? Please understand what is osmotic pressure. Now, let us suppose here this flow is happening, right? And here we have vapor pressure of A chamber is high, vapor pressure of B chamber is low. What happens if I add an external pressure? I add external pressure, and what amount of external pressure, and till when should I add external pressure? So we say that if I add an external pressure, so much so that the osmosis stops, that the osmosis stops. In order to stop the osmosis, I will have to apply such a pressure that the vapor pressure of chamber B becomes equal to the pressure of chamber A. That is known as, that pressure, that external pressure is known as the, that external pressure is known as the osmotic pressure. So what is osmotic pressure? A simple definition of osmotic pressure is, please write, the pressure which just stops the osmosis, which just stops the osmosis, is called osmotic pressure. Is everyone done writing? Yes or no? Please tell me. Let me know if you are writing. Now, this osmotic pressure, it is equal to CRT. Osmotic pressure, it is equal to CRT. This pi is the osmotic pressure. T, it is the concentration. Concentration in moles per liter. So basically it is molarity. R is gas constant. And T is the temperature in Kelvin. Okay. Now, please write next. Here we have concentration in moles per liter. So I can write pi, it is equal to the number of moles of solute divided by the volume of solution into R into T. Then what else I can write? I can write pi, it is equal to number of moles, it is equal to WB divided by the molar mass of the solute multiplied by the volume of solution, RT. Okay. Now, what I can write from here is that MB, determination of C, generally we use molar mass. So we use this equations to calculate molar mass. So molar mass will be equal to mass of the solute multiplied by R into T divided by the osmotic pressure and volume. Please remember the volume should be in liters. Okay, this volume should be in liters. Okay, please write this down. After this, write a note. This question has been asked once in the board examination. Okay, so you can expect this sometimes also. It's never been asked again. Please write. Osmotic pressure, it is generally, it is what it is, used for the determination of molar masses of macromolecules, large molecules such as proteins and polymers. Why? So that was the question actually. So please write the answer. OP, that means osmotic pressure, is used for the determination of molar mass. Determination of molar mass of macromolecules, such as proteins and polymers, due to ease of measurement, ease of measurement, and significant accuracy. And significant accuracy. Next, we'll write biological importance of OP. So osmotic pressure, it is used for whenever there is mixing of solution, no, then we should take care of osmotic pressure. Mainly when we are having mixing of solutions in our body. So see, we drink water, water gets processed and everything, right? But when we put saline, pani chahta है किसी आदमी को, then what is happening? We are having a solution and it is directly entering our body, not through our stomach. It is directly getting into our bloodstream, right? That's saline water. So the concentration of saline water should be a specific concentration, and it should be this concentration should be determined taking care of osmotic pressure. If you don't know the osmotic pressure of our blood, then we should not be handling those those solutions. So the blood, it has a osmotic pressure which is equal to a solution which is 0.91% mole by mass by weight, mass by volume, mass by volume of saline water. So first of all, write that point. 0.91 percentage mass by volume of saline water has same osmotic pressure as that of blood. That means, basically speaking, now blood is obviously, it is not a solution, it is not a binary solution. It is having many things in it, right? So whatever be the solute in the blood, its osmotic pressure is equal to that of saline water. Now, when we are going to, so we can assume that the concentration of blood is equivalent to that of 0.91% mass by volume saline water. Now, whenever we are going to add a saline water or any solution, it can be of three types. If I compare it with blood, it can be of three types. It can be of three types, please write. Now, it can be of three types. First is concentration more than blood cell. More than blood cell. Now, this type of solution, it is known as hypertonic solution. What it is known as? It is known as hypertonic. Now, when hypertonic solution is added in our bloodstream, please remember the concentration is high. A concentration of what is high? This concentration of the solution is high. When the concentration of the solution is high, that means solvent is less. So what will happen? Osmosis will take place, and osmosis will happen from RBC to the solution. So please write solvent. What is solvent actually? Solvent is water. In RBC, what is solvent? Solvent is water. Solvent will move from RBC to the solution. Now, if something is moving away from the red blood cell, then obviously the size of red blood cell will shrink. So we'll say RBC will shrink. Now, this is the consequence. Now, next point, please write. If the concentration is same as blood cell, same as blood cell, then this type of solution is known as isotonic. So what happens here? Nothing happens here actually. Nothing happens. And we can write, sorry, RBC remains the same, right? RBC remains the same. Now, if we are going to add concentration less than blood cell, then what is going to happen? Please see. Hypotonic solution. Hypotonic solution. Now, in hypotonic solution, what is going to happen? See, the concentration in the concentration of the solution is less than blood cell. When the concentration of solution is less, solvent is more. So solvent will move from the solution to the RBC. Please write solvent moves from the solution to RBC. Now what is going to happen? Therefore, RBC will swell up. Therefore, RBC will swell up. Okay, right. Next, see, this is the first thing. Another point is that, right, if we add too much salt in our diet, right, then what is going to happen? If we have too much salt in our diet, then the solution, that means the lipids and everything, what is going to happen? They will become too much salty. They will become too much salty. And when the solution and everything is very much salty, whatever drink, water we are drinking and whatever fluids we have, if the fluids is too much salt, it's having too much salt, then the tissues which are having salt, they will, what will happen? They water from those tissue will move away and it will be retained under the what I can say, retained inside the tissues, right? Not inside, rather outside, but it will be not excreted by our body. It will get away from the tissue, but it will remain in our body, which causes generally some type of swelling. And those swelling is generally present in older people. If you see, they're like the skin below the eyes, right? So it generally sometimes swells up, and that swelling is because of a lot of eating of lot of salt in our food. Okay, so that is the next point. Please write people taking lots of salt. People taking lots of salt experience water retention in tissues and intercellular spaces. And intercellular spaces. Resulting in puffiness and swelling. This condition is known as, this condition is called edema. Okay. Another question is that is generally asked, and which is the application of osmosis, is regarding the salting of meat and adding sugar in fruits. So when we want to preserve a food item, we add, if it is made with salt, we generally preserve that food item by salting it. And if it has to contain sugar, I mean, if it is sweet thing, then we generally add sugar to, then we add sugar to preserve it. Now, why that is done, please write salting in meat and adding sugar in fruits results in loss of water, results in loss of water, and the bacteria dies. You see, bacteria can only exist if there is water. If there is no water, the bacteria won't exist. So in order to remove those water, what we do, we add sugar or we add salt in these. Okay, write this down. And the last point regarding osmosis will be reverse osmosis. So reverse osmosis is a very simple process. What we do is, well, let us suppose we have two chambers once again. And in these two chambers, we have one chamber with pure solvent, pure water, I would say. And here we have salt water or impure water. Okay, impure water. And we have certain openings like this, and the opening will be here somewhere. Okay. So let us suppose the water level is here. So water level is here, let us suppose like this. And it is here, let us suppose like this. And this is the outlet actually. So the outlet, you have outlet something like this. Okay. Now we apply pressure on the side of impure water. If apply pressure in the side of impure water, and how much pressure is applied, please see. The pressure is greater than the osmotic pressure. Okay, so osmotic pressure, it stops the osmosis. But if I add even more pressure, then what is going to happen? Reverse osmosis. So from impure water, what is going to happen? The water is going to move. Please remember, only water, only solvent, only H2O. The salts or the impurities are not going to go away. They are not going to move with the water because we have a semi-permeable membrane, which is, this is the semi-permeable membrane, which only allows water to move. That is why what will happen, we will get pure water here. And we have pure water, here we have impure water. We apply pressure higher than osmotic pressure, then rather than osmosis, what happens? Reverse osmosis. Okay, so please write here the movement of solvent through SPM from a solution of higher concentration के ब्रैकेट में लिख लीजिए impure to lower concentration, ब्रैकेट में लिख लीजिए pure to lower concentration by applying external pressure by applying external pressure on the impure side. Is called RO.
Sir, what is SPM?
Semi-permeable membrane. Is everyone done? Yes or no? Please tell me. By the way, guys, please check the WhatsApp group after class. Okay, so there's a poll. Can you please vote on that poll so that I can decide what chapter to start from tomorrow till 26th? See, this is again, and I've written everything that whatever chapter you choose, it will be taught in your regular classes also. But it will not be taught now, it will be taught later on. Okay. Because in all the batches we are going with organic chemistry. So organic chemistry, until unless it is completed, I will not start any other thing. Okay. So in your regular classes, it will be taught, but after we have completed the organic chemistry. So you have to choose one chapter here. And also please remember, I am not adding electrochemistry here because I cannot complete any cannot even handle electrochemistry in 22 to 26 hours, right? In 4 days. Also 1 hour of classes. You will not even understand anything. So I've chosen small chapters, biomolecules, and then we have DNF block. Girls, I'm just typing in your group, okay? DNF block. And then we have chemical kinetics, which I can deal in 4 days. It's not a very big chapter. Okay, so can you guys please vote now? You have to select only one, okay? Don't select multiple. I think I have given this option of selecting one or more. Oh, is WhatsApp already having this? I think select one or more. Guys, please. Is Rabia in the class? राबिया को तो एक बार हम केमिकल काइनेटिक्स पढ़ा चुके हैं, उसको फिर से पढ़ना है केमिकल काइनेटिक्स. Okay, I can see chemical kinetics winning here. And in boys match, biomolecules is winning. So obviously, whatever is getting more votes, it will be thought. Okay, I will just look and okay. I think many people have voted till now. Hafsa voted what? Hafsa is also voting for chemical kinetics. ठीक है चलिए. I think chemical kinetics is going to win because we have 5 votes for chemical kinetics and only 2 votes for biomolecules, and that is in the boys group. No one has voted for biomolecule DNA block in the girls. Okay, चलिए. Thank you. So approximately हमको idea लग गया chemical kinetics करेंगे हम लोग. ठीक है. Okay, right now, please write quickly. Abnormal molar mass. Now, what is abnormal molar mass? Please understand this. Leave your pen aside, stop the voting and everything, and try to understand what is abnormal molar mass. Please see. Let us suppose we are having a solution. Let us suppose we are having a solution, and in this solution, we are having a solvent only, and in this solvent we have added 1 mole of NaCl. 1 mole of NaCl. And we have added 1 mole of NaCl. We have added 1 mole of NaCl. Whatever calculations we will be doing, we will be taking into consideration the amount of solute, the number of moles of solute that is equal to 1 mole. Enough. So we are thinking we have added 1 mole of solute only. But as soon as NaCl it gets inside a solution, such as water, NaCl will dissociate into Na positive and Cl negative. Okay, so we are thinking that we have added 1 mole of solute particles, but the solution experiences. See, if I have 1 mole of NaCl, I will get 1 mole of Na positive, 1 mole of Cl negative. So basically, the solution, it is experiencing 2 moles of solute. 2 moles of solute in whatever amount of water is present. We were doing all the calculation using what? 1 mole. And essentially, we have added 1 mole only. But the solution is experiencing 2 moles. That means whatever calculation we are doing, and basically we do the calculation for the determination of molar mass of the solute. That molar mass of the solute, if we use the experimental value, whatever experimental value we are getting for the colligative property, that will come out to be abnormal. That will not be correct actually. Okay, it will not be correct. Why it is not correct? Because the solution is experiencing 2 moles and we are doing all the calculation using 1 mole. All of you got this? Yes or no? Please tell me. Anji, बताएं. All of you understood this? Yes or no? Please tell me. The problem, what is happening?
Yes, sir.
Okay. Now, that is why, please write, for substances for substances होता है, substances होता है, भूलिए substances होता है, substances, what he's right, substances, हाँ, substances undergoing dissociation or association, in solution their molar mass determined from colligative property is different from the actual molar mass. This experimentally determined this experimentally determined colligative property, sorry, this experimentally determined molar mass from colligative property is called abnormal molar mass. Abnormal molar mass. Okay. Now, whatever abnormality in the molar mass that is coming, that means we are not getting the actual molar mass. That is only, and it is only because of what? Just a second, guys. Let's understand. This is experimentally determined. Okay. Now, whatever abnormality is coming, it is because of the dissociation of the solute particles. Now, how much dissociation is taking place? The more dissociation takes place, the more abnormality will be there in the colligative property. And to measure the dissociation and association, we have a term that is known as Van Hoff factor. Is right? Van Hoff factor. Van Hoff factor, it is given by I. And what is I? Simply I, it is equal to the experimentally determined colligative property divided by the colligative property which is calculated. Okay. Now, please remember, if you look at any colligative property, let us see delta TB, it is equal to KB into WB into 1000 divided by MB into WA. If you do see delta TF, it is also equal to KF into WB into 1000 divided by MB into WA. If you look at pi, we have seen just now, is equal to WB divided by WBRT divided by MB into the volume. What you can see, all of these colligative properties, they are inversely proportional to the molar mass. If the molar, see, all of the molar mass, all the time molar mass is coming in the denominator. That is why I can write a point that colligative property, this is inversely proportional to the molar mass of the solute, the molar mass of the solute. Now I can define I with respect to molar mass also. See, colligative property experimental will have the molar mass on the denominator. That means molar mass that is determined experimentally. Now CP calculative, so CP colligative property that is determined by calculation. Now this will have the molar mass on its denominator, and it will become denominator of denominator, which is numerator. So we'll have MB in the numerator here. So what I can write here, this is what normal calculation से क्या रहा आपको, normal molar mass divided by abnormal molar mass. By the way, right now the timing of this class is 10 a.m. to 11 a.m. No, 12:30 10 a.m. हाँ ठीक, चलो टाइम डालना भूल गया था. Also, I will be equal to number of particles after association or dissociation divided by number of particles before association or dissociation. Probably it is going to be chemical kinetics. जो केमिकल काइनेटिक्स में वोट करके वो लोग अगर नहीं आए ना, आपको हम बताएंगे रेगुलर क्लासेस में. फिर those who have voted for chemical kinetics and if they don't attend these classes, बढ़िया से डांट लगेगी आप लोग को. रेगुलर बैचेस में तो आइएगा. ऐसे तो बिल्कुल अलार्म लगा लीजिए आप लोग 8 बजे से लेकर 10 बजे कि उठ ही जाना है जो भी हो जाए. ठीक है, सोते नहीं रहना है बिल्कुल. बात समझ में आ रही है? या हफ्सा, आप ही लोगों ने वोट किया ना? हाँ जी. What are these people? हफ्सा, डेबोरा, राबिया, मरियम पार्कर एंड फिया. ठीक है, यहाँ पे डेबोरा है और फिया है, हफ्सा भी है. ठीक है, राबिया पता नहीं क्यों पढ़ना चाहती है. राबिया भी ऊपर पढ़ा चुके हैं. राबिया केमिकल काइनेटिक्स पढ़ाया भी जा चुका है. पता नहीं कितना शॉर्ट होता है मतलब पीएचडी करेंगे है चलिए now depending on these Van Hoff factors we have to modify the equations of colligative property please write modification in equations of colligative property. So we just multiply I here. So in general, a colligative property. Now see, whenever they will tell you na, that elevation in boiling point was found to be this much, depression in freezing point was found to be that much, right? All of these things. Then what you need to do, please understand that all of these things are what? All of these things are experimentally determined. So colligative property, जो आपको दिया जाएगा delta TB, delta T कुछ भी, that is experimentally determined. It will be equal to I into whatever the formula is there na. For example, osmotic pressure CRT. So CRT यहाँ पे आ जाएगा. I will tell you what is actually meaning calculator. Now, for example, if I have RLVP, number one is RLVP. Now in this case, P naught A minus PS divided by P naught A. This is going to be the experimentally determined thing. Na? This will be equal to I times chi B. This is the relative lowering of vapor pressure. Secondly, right? Elevation in boiling point, which is what? Which is delta TB. So delta TB will be equal to I into KB into M, which is whether you can write I into KB into WB into 1000, right? Divided by MB into WE. So this part is experimentally determined. And you don't have to do calculation. How will you do calculations, right? I mean, temperature is experiment. They can ask you that you plug in these values and then calculate, determine the delta TB. But generally speaking, the temperature is an experimentally determined thing. Third is delta TF. So I can directly write I into KF into WB into 1000. This whole thing will be divided by MB into WA. Now, fourth is the osmotic pressure. So pi will be equal to I into CRT. Okay. Now, as you can see, if I increases, then what is going to happen? The colligative property is also going to increase. So you can directly write one thing very crucial. Colligative property is directly proportional to I. That means if there is a molecule which is getting dissociated into many different ions, then it will have a higher colligative property. Right, next, determine the value of I matter factor in following. Number one, देखिए NaCl वगैरह का तो आपको पता होगा, ठीक है ना? NaCl हो गया, MgCl, कुछ आप लोग को बता रहे हैं, NaCl LiCl तो कर लीजिएगा आप लोग. For example, you have MgCl2. Secondly, let us write K2SO4. Third, you can write Na2SO4, which is similar. Fourth, you can write NH4NO3. ammonium nitrate. Fifth, you can write KNO3, similar. Sixth, you can write Al2. SO4 whole thrice. Okay. So please see here. Please see. In MgCl2, it will dissociate into Mg2 plus and 2Cl negative. K2SO4, it will dissociate into 2K positive and SO4 2 negative. Na2SO4, it will dissociate into 2 Na positive and 1 SO4 2 negative. NH4, it will dissociate into NH4 positive and NO3 negative. KNO3, K positive, NO3 negative. In Al2, it will dissociate into 2 aluminium 3 positive plus 3 SO4 2 negative. Okay. So as you can see, the I will be equal to how much here? 2 plus 1, that is equal to 3. The I here will be equal to 2 plus 1, that is equal to 3. Here also I will be equal to 3. Here 1 and 1, so I will be equal to 1. Here 1 and 1, so I will be equal to 1. Here we have 2 and 3, that means I will be equal to 5. Now there is a special case of benzene. Please see that. Seventh one, please write benzene. Sorry, not benzene, benzoic acid. Benzoic acid. Now, benzoic acid, it has a formula C6H5COOH. Now, benzoic acid, so obviously it is acidic in nature, but acid in nature only if you have water. Okay, if you have H2O, then what will happen? It will dissociate into C6H5COO negative plus H positive. In this case, the I is equal to 2. But in the presence of benzene, that means there is a non-polar solvent. So C6H5COOH. In the presence of benzene, what happens? It associates rather. The presence of benzene. So we'll get C6H5COOH. This whole thing will be twice. Okay, this whole thing will be twice. Abhi to sab log padhenge na benzoic acid. We'll be doing aldehyde ketones carboxylic acid, then you will understand how it is getting actually associated. So in order to balance it, what you need to do, you need to add here 2, right? Now everything is balanced in this benzene one. Okay. Now if you see I is equal to the number of particles after dissociation. So how many particles? Here we have only one. One particle. This is one molecule of H2. Okay, this is one H2 mein do nahi hai. H2 is one molecule of H2. Please understand that. So you'll have one molecule, and before dissociation or association we have 2. So this will be I will be equal to 2. Now one important point that you can find from here is, से बहुत बार सवाल आया है, for association the value of I, it is less than 1. It is less than 1, and for dissociation the value of I is greater than 1. Okay. Write this down quickly. देखिए इसमें आपका काम बचेगा. Everything is there in your notes. Okay, don't worry about that if something is not. See, I have given all the example. कहीं आपको ये भी नहीं फंसेगा कि सर इसका I की वैल्यू क्या होगी. अब उसके बाद फिर आपको थोड़ा दिमाग, अगर कैल्शियम क्लोराइड आ जाए, कैल्शियम क्लोराइड और मैग्नीशियम क्लोराइड सेम ग्रुप के एलिमेंट्स हैं, तो उतना आपको दिमाग लगा करना पड़ेगा. NaCl का कोई हमसे I पूछे तो हम बोलेंगे ये तो आपको पता होना चाहिए. ठीक है. Otherwise, many of these here, you must know that they will break into what ions. For example, Al2SO4 whole thrice में आपको confusion हो सकता था. NH4NO3 भले ही आपको पता हो, थोड़ा confusion हो सकता था. वो सारी चीजें हमने लिख दी है ना. I've given everything here. In the case of benzoic acid, even though CBSE has not asked till now that what will happen in H2 and what will happen in benzene, But in the questions they have given two different types. And even in NCERT, if you are going to see, then you will see that sometimes benzoic acid is associating, sometimes it is dissociating. That is why I told you that also. Don't have any confusion. So जो पूछेगा सर बेंजोइक एसिड आएगा तो क्या करेंगे, जो थोड़ा पढ़ाई लिखाई करते हैं ना उनके अंदर ये डाउट आता है, बाकी लोगों में डाउट भी नहीं आता है. Because solution is a huge chapter. वो azeotrophs में पागल हो जाते हैं बच्चे. Oh my God, what is happening? Ideal solution, non-ideal solution, positive deviation, negative deviation. थक जाते हैं वहीं पे. Qualitative property पहुंचते पहुंचते 100 से बच्चे पहुंच जाते हैं 30 तक. After they have learned qualitative, 4 qualitative properties. Oh my God, इतना बड़ा बड़ा formula KB into WB into 1000 divided by NB into W, पूरा दिमाग लगाते हैं. KB तो WB, BB BA, BB BA, ऐसे याद करेंगे बच्चे, है ना. पागल थक जाते हैं. अब उसके बाद आता है abnormal molar mass. अब सोचिए qualitative property, till you are here at qualitative property, 70% of the students are tired already. There are only 30% students remaining in qualitative property. फिर उनका दिमाग जानते कब खुलता है? When half yearly is done, and half year में they are asking only about what, or they are only asking about the qualitative properties. Then even okay fine, qualitative property is also something you have to learn that also. And then when they come and see abnormal molar mass, वही भूल जाते हैं abnormal molar mass क्या है. एक्सपेरिमेंट से गलत आ रहा है आंसर, मतलब एक्सपेरिमेंट क्यों कर रहे हैं, ठीक है. तो वहां पे कंफ्यूज हो जाते हैं बच्चे. आई हैव टोल्ड एवरीथिंग हियर ना, व्हाट इज हैपनिंग, व्हाट इज नॉट हैपनिंग आल्सो. इसके बाद भी एक टॉपिक, ठीक है. वहां तक पहुंचते पहुंचते तो मतलब बच्चे का साल गुजर जाता है, बच्चों को बाद में पता चलता है, 12th करने के बाद पता चलता है अच्छा ये 12th में था, ठीक है. प्लीज सी नेक्स्ट थिंग फॉर वीक इलेक्ट्रोलाइट्स. दिस इज द केस ऑफ स्ट्रॉन्ग इलेक्ट्रोलाइट्स, है ना. इन द क्वेश्चन यू विल सी let us suppose this much gram of this solute was added in water, है ना, and calculate the osmotic pressure, calculate the elevation in boiling point or depression in freezing point, assuming that it is completely dissociated. That it is completely dissociated. That means there are cases in which it is partially dissociated, and obviously we know whenever things break, I mean whenever you have electrolyte will break, and will break either, it will be either a strong electrolyte that means breaking up 100%, or it will be a weak electrolyte breaking up only 50%, right? So for weak electrolytes, please see here the case of weak electrolytes. अब यहाँ पे देखिए एक्स्ट्रा क्लास है, अगर रेगुलर क्लासेस रहती तो हम तो सब कुछ कराते ही आप लोग, ठीक है ना. वीक इलेक्ट्रोलाइट्स में लेकिन हम आपको बता दे रहे हैं. अब इसमें जो हम थ्योरी पढ़ा रहे हैं इसके ऊपर सवाल आप लोग लगाइएगा. You will do the questions. Wahan you will have doubt. You are going to have doubt. You will not even understand the question. And then you will WhatsApp me the question. I will see those who have messaged me anytime with a doubt. I always reply. It has not that I have anytime I have not ignored any messages. I don't ignore those messages. Okay? So you will ask me the question. I will reply over WhatsApp. And I hope now, by now, you know that I'm not going to give you the answer. I mean, I will reply, but my reply will be see that part of the note. Think in that order, think in that way, try to, I'm on the level of the question. See, if Hafsa is asking a question and Fia is asking a question, and the questions are also same, but my replies will be different for both of them because both of them need help in different directions. Okay, so one thing, please understand that I'm not going to give you the answer when you ask me the questions. Okay, so I will tell you. Basically, in numericals, I do this, that I will tell you, think in this order or think in that way, and that is going to help you understand. ठीक है. चलिए, इन वीक इलेक्ट्रोलाइट्स लिख लीजिए. थ्योरी आपके पास है पूरी, ऑल द फॉर्मूला एंड एवरीथिंग विल बी देयर. यू जस्ट नीड टू अप्लाई इट, और उसके लिए आपको बैठना पड़ेगा एक बार. थोड़ा ऐसे अपना सर खुजाइएगा आप लोग, है ना, परेशान होइएगा, थोड़ा गाली बकिएगा हमको. मास्टर कैसा पढ़ाता है, बोलता है कि हम आंसर भी नहीं बताएंगे, है ना. हमको बोलता है व्हाट्सएप करो, हम बोलता है, फिर बोलता है हम आंसर भी नहीं बताएंगे, है ना. फिर उसके बाद थोड़ा सा गाली वाली बक के हमको, आप लोग हमको व्हाट्सएप कीजिएगा, ठीक है ना. सर बता दीजिए सर, then I will push you guys. No, think in this way, think in that way. Okay. ये इतना कीजिएगा आप लोग तब तो. For weak electrolyte. Now in weak electrolytes we will have two cases, association and dissociation. So please write here association. In here we write dissociation. So whenever there is weak electrolyte, there is degree of association and degree of dissociation. Degree of association and degree of dissociation. Okay. Now, here, first of all, right? Beta is degree of association. And for dissociation, we write alpha. Alpha is degree of dissociation. Degree of dissociation. Okay. Now, for association, what happens? I, that is the Van Hoff factor. I, it is equal to 1 plus beta into 1 upon n minus 1. For dissociation, I is equal to 1 plus alpha n minus 1. Alpha into n minus 1. So this is when they are asking you about Van Hoff factor, and that means you will they have given you the degree of association and or degree of dissociation, and they're asking you Van Hoff factor. But sometimes what can happen, you will be having the Van Hoff factor and you need to determine the alpha and beta. So in that case, please write beta is equal to 1 will go there, it will become I minus 1 divided by this whole thing 1 by n minus 1. Here you will have alpha, it is equal to I minus 1 whole divided by n minus 1. Now in both the cases, n is equal to number of particles in dissociated form. Association or dissociation kaise hoga? See here, guys. In association, how we can have dissociation? Please see. But suppose we have C6H5 COOH in benzene, right? In benzene. So association will take place. So we'll have C6H5 COOH whole twice. So this is the associated form. This is the associated. So what is this? This is the dissociated form. And now balance it, you will get 2. Right? So what is N in this case? N is equal to. So this is the dissociated form. No? But when I take NaCl, it is going to give me Na plus and Cl negative. Now here, this is the dissociated form. So what is the N here? It is also equal to 2. Okay, so everything is present in your notes now. You start doing the questions. If you will do the question in NCERT, then you will have doubts. And when you have doubt, please WhatsApp me those doubts. Okay. So thank you guys. Thank you very much. And hopefully from tomorrow, let me see the votes right now. Okay, so chemical kinetics is winning. Degree of association. Yeah, degree of association. Degree of association, degree of dissociation. By the way, these formula, they are not just ऊपर से ऐसे नहीं आ गए हैं. You can derive these formula, but it requires a lot of portion from equilibrium. Okay, and equilibrium is in 11th standard. Okay, so I could not bring up my courage. है ना, इतनी मेरी हिम्मत ही नहीं हो रही है कि हम इक्विलिब्रियम आप लोग को पढ़ाने से स्टार्ट करें. आप लोग जवाब ही नहीं देते हैं कुछ. ठीक है ना. सो याद करना है बेसिकली आप लोग को ये फॉर्मूला. ठीक है. एंड दोस हु आर लकी इनफ to watch the recordings, they can watch the recordings in the regular classes. Obviously we have more time now. तो उस वक्त हमने इनको derive किया था. See, please trust me when I teach less also. Okay, I took a lot of classes for organic chemistry, if you remember, है ना. बोलिएगा सर हम लोग को फुसला के ऑर्गेनिक केमिस्ट्री इतना क्लास करा दिए, केमिकल सॉल्यूशंस इतने हल्के में टपका देते हैं, केमिकल काइनेटिक्स इतने हल्के में टपका दे रहे हैं ना 4 क्लासेस में. So please understand that I have given organic chemistry a lot of time because that you have to, the other chapters, they depend on those things whatever we have taught in organic chemistry, haloalkane, halorine, and also the basics. Okay, but solution, these things, weak electrolyte, strong electrolyte, it is not, none other chapter are depending on these things, these topics that we are talking. So if you are doing solutions, you are only doing solutions. But if you are doing haloalkane, halorine, then you are doing something from alcohol also. If you're doing alcohol, then you're doing something from haloalkane as well as something from aldehyde also. Okay, that is why it was very important to get the organic chemistry concepts crystal clear, and also because अब हम aldehyde पढ़ाएंगे आप लोग समझ नहीं आएगा. ठीक है, तो उसमें बहुत दिक्कत होती है. Now those who have not done solutions, even if they do chemical kinetics, they will understand everything in chemical kinetics. So chemical kinetics is not dependent on solution. That is why we have taken less number of classes. We have not done too many numericals here. Okay, so whenever you want to do numericals, you can do those numericals. When you will go to do the numericals, half hour before, you will just make a formula sheet of solution chart and just revise that formula chart and then start doing the numericals. And once you start doing the numericals, then you will understand how to do that. Okay. So if you start now, then also it is going to work. If you start a week later, then also it is going to work. But if this does not happen in organic chemistry, I'm speaking by experience. That is why I have taken good amount of time for organic chemistry, but not that much for physical chemistry, because I know the importance of both of them. Okay. So please trust me in these things when I choose less number of lectures. Please don't assume anything. And I think some of you may